Alright, let's start with methane. First, take a look at the atom key. Carbon has 4 valence electrons, while hydrogen has just 1. Now place carbon in the center and arrange 4 hydrogen atoms around it. Here's what happens next. 1 electron from carbon meets 1 electron from hydrogen, creating a shared pair. The same thing happens 4 times, so we get 4 single carbon to hydrogen bonds. Take one final look at the structure. Carbon is now surrounded by 8 electrons, and each hydrogen is surrounded by 2. That completes the Lewis structure for methane. Next, let's build ethane. Once again, carbon has 4 valence electrons, and hydrogen has 1. Start by placing the 2 carbon atoms next to each other. Then, attach 3 hydrogen atoms to each carbon. Now watch the electrons. 1 electron from each carbon comes together to form the carbon-to-carbon shared pair. The remaining carbon electrons pair with hydrogen electrons. Altogether, 7 shared pairs form 7 single bonds. Notice that both carbon atoms now have complete octets, while every hydrogen has 2 electrons. And that gives us the finished Lewis structure for ethane. Now let's move on to ethene. This is where we meet our first double bond. Carbon has 4 valence electrons, and hydrogen has 1. Place the 2 carbon atoms in the center, with 2 hydrogen atoms attached to each carbon. First, each carbon shares 2 electron pairs with hydrogen. If the carbon atoms shared only 1 pair with each other, each carbon would still have only 6 electrons around it. So here's the key step. The carbon atoms share 1 more pair. 2 shared pairs between the same carbon atoms create a double bond. Now both carbon atoms have complete octets. Alright, now let's look at ethene. Carbon has 4 valence electrons, and hydrogen has 1. Arrange the atoms in a straight line. Hydrogen, carbon, carbon, hydrogen. Each hydrogen shares 1 electron pair with the nearest carbon. But notice that a single carbon-to-carbon bond would not complete either carbon's octet. So the 2 carbon atoms share 2 additional pairs. That gives us 3 shared pairs between the carbon atoms, which form a triple bond. The final structure is hydrogen single bond carbon, triple bond carbon, single bond hydrogen. Both carbon atoms now have 8 electrons around them. Next up is nitrogen gas. Because both atoms are nitrogen, we only need to show nitrogen once in the atom key. Each nitrogen has 5 valence electrons. Now bring the 2 nitrogen atoms together. A single shared pair would still leave both atoms short of an octet. So the nitrogen atoms bring 3 unpaired electrons from each side into the bonding region. These electrons form 3 shared pairs, giving us a nitrogen-to-nitrogen triple bond. Notice that 1 lone pair remains on each nitrogen. With the triple bond and the lone pair, both nitrogen atoms now have complete octets. Now let's draw ammonia. Nitrogen has 5 valence electrons, while hydrogen has 1. Place nitrogen in the center and arrange 3 hydrogen atoms around it. 3 of nitrogen's unpaired electrons each meet 1 hydrogen electron. That creates 3 shared pairs and 3 single nitrogen-to-hydrogen bonds. But nitrogen still has 2 electrons left. Those 2 electrons stay together as 1 lone pair. So in the final structure, nitrogen has 3 bonds and 1 lone pair. Nitrogen reaches an octet, and each hydrogen reaches a duet. That is the complete Lewis structure for ammonia. Let's continue with hydrogen cyanide. Hydrogen has 1 valence electron, carbon has 4, and nitrogen has 5. Arrange the atoms in a straight line. Hydrogen, carbon, nitrogen. Hydrogen and carbon share 1 electron pair, forming a single bond. Now focus on carbon and nitrogen. 1 shared pair is not enough to complete carbon's octet, so they form 2 additional shared pairs. This creates a carbon-to-nitrogen triple bond. Nitrogen keeps 1 lone pair, so the finished structure is hydrogen single bond carbon, triple bond nitrogen. Carbon and nitrogen have octets, and hydrogen has 2 electrons. Now let's look at methylamine. Carbon has 4 valence electrons, nitrogen has 5, and hydrogen has 1. Start by connecting carbon to nitrogen. Then place 3 hydrogen atoms around carbon and 2 hydrogen atoms around nitrogen. Each connected pair of atoms shares 1 electron pair. That gives us 1 carbon-to-nitrogen bond, 3 carbon-to-hydrogen bonds, and 2 nitrogen-to-hydrogen bonds. In total, there are 6 single bonds. Notice that nitrogen still keeps 1 lone pair. Carbon and nitrogen both have complete octets, while each hydrogen has 2 electrons. And that completes methylamine. Alright, let's move to oxygen gas. Since both atoms are oxygen, oxygen appears only once in the atom key. Each oxygen has 6 valence electrons. Bring the 2 oxygen atoms together. If they shared only 1 pair, each oxygen would still have an unpaired electron. So they share a second pair as well. 2 shared electron pairs between the oxygen atoms create a double bond. Now look at the electrons that remain. Each oxygen keeps 2 lone pairs. With the double bond and those lone pairs, both oxygen atoms are surrounded by 8 electrons. That gives us the complete Lewis structure for oxygen gas. Next, let's build carbon dioxide. Carbon has 4 valence electrons, and oxygen has 6. Place carbon in the center, with 1 oxygen atom on each side. At first, imagine 1 shared pair in each carbon to oxygen connection. Carbon would still be short of an octet. So 1 more shared pair forms on the left, and another forms on the right. This creates 2 carbon to oxygen double bonds. Each oxygen keeps 2 lone pairs. Notice that the final molecule is linear: oxygen double bond, carbon double bond, oxygen. Carbon and both oxygen atoms now have complete octets. Now let's draw methanol. Carbon has 4 valence electrons, oxygen has 6, and hydrogen has 1. Arrange the atoms as H₃COOH. Carbon shares 3 electron pairs with 3 hydrogen atoms and 1 pair with oxygen. Oxygen then shares 1 more pair with the final hydrogen. That gives us 5 single bonds altogether. Now notice the oxygen atom. After forming 2 bonds, oxygen still has 4 non-bonding electrons. These remain as 2 lone pairs. Carbon and oxygen both reach complete octets, and every hydrogen has 2 electrons. That is the Lewis structure for methanol. Next, let's look at ethanol. Carbon has 4 valence electrons, oxygen has 6, and hydrogen has 1. Build the skeleton as H₃CCHO. First, connect all the atoms with single bonds. Now focus on the second carbon. At this stage, it has only 6 electrons around it, so its octet is incomplete. Here's the important step. 1 lone pair from oxygen becomes an additional shared pair between carbon and oxygen. This creates the carbonyl double bond. Oxygen keeps 2 lone pairs, all other connections remain single bonds, and both carbon atoms finish with complete octets. Now let's move on to ethanoic acid. Carbon has 4 valence electrons, oxygen has 6, and hydrogen has 1. Build the skeleton as H₃CCOOH. The central carbon connects to both oxygen atoms. 1 oxygen is also connected to hydrogen. If all 3 connections around the central carbon were single bonds, carbon would have only 6 electrons. So 1 lone pair from the oxygen without hydrogen becomes an additional shared pair. This forms the carbonyl double bond. The second oxygen remains single bonded to carbon and hydrogen. Both oxygen atoms keep 2 lone pairs, and every octet is complete. Finally, let's draw methyl ethanoate, also called methyl acetate. Carbon has 4 valence electrons, oxygen has 6, and hydrogen has 1. Build the main skeleton as H₃CCOCH3 and attach the second oxygen to the middle carbon. Now focus on that middle carbon. With only 3 single bonds, it would not have a complete octet. So 1 lone pair from the terminal oxygen becomes an additional shared pair, creating the carbonyl double bond. The other oxygen forms 2 single bonds in the carbon-oxygen-carbon connection. Both oxygen atoms keep 2 lone pairs, and all carbon atoms finish with complete octets.